Okay. Hi, everyone. So my name is Ali, and I have a problem. Around about 10 years ago, I started looking at cloud costs as part of my PhD. And back then, there was only about 10,000 price points, and I was scraping them manually. Today, there is more than 3 million price points between AWS, Azure, and Google. And it's been 10 years, and I don't know why I'm still building tools for cloud costs. I don't know why I have this unhealthy obsession with cloud prices. And this is the thing that's been bothering me for the last year or so. So here is what the checkout experience looks like for an engineer buying cloud resources using Terraform on AWS. But the same could be said with CloudFormation, Pulumi, and any other infrastructure provisioning tools. So I run Terraform apply, and it says it's going to add 18 resources. 4 things are being changed, 2 things are being destroyed. And I'm like, yeah, that looks okay. That's fine. And it goes live. And months of this happen until eventually the cloud budget is blown. And that's when this pain train starts, when usually the CFO takes a dump on the VP of engineering, who then takes a dump on the engineering management, who then take a dump on the development or SRE or DevOps teams. And I'm like, what did you expect? Nobody saw costs in the checkout screen, and nobody really understood what they were buying. So of course, like, it was going to happen. And I think regardless of whether you're buying a t-shirt or EC2 instances, you should know the costs before you're buying stuff. Just going to move this on the side. So Infracost is this open source project, and in the same way that Terraform shows you a diff of what's about to be applied, Infracost shows the same thing, but using a cost dimension. So you can see, like, this instance change is going to reduce your cost by about $125, and this Lambda that you're adding is going to add a bunch to your costs. I'll talk a bit about the challenges of estimating these usage-based resources in a minute. But once you have the CLI, you can then put it in pull requests using any CI/CD integration like GitHub Actions. So you can see a screenshot here, and it's cool because at the same time that teams are discussing potential security issues or performance issues, why not costs? So what are the benefits of doing that? Here's the things we are seeing in the community. First and foremost, enables people to reduce the costs. So usually what we see is someone's changing like a staging environment, and they're changing like some Terraform modules, and they're wondering, if I change the module to use single AZ instead of multi-AZ across all these staging databases, how much does that save? And is that worth the effort or not? Because it does require like a CI/CD pipeline to roll and us to deploy. We're seeing people who want to implement a cost-aware culture, and they want to discuss costs during code reviews, and this kind of enables that. Some teams are using it as a safety net. That extra 0 you add on to your IOPS accidentally, or that instance type that you didn't know was going to be costing you $5,000, these accidents happen far more than you would think they do. And this can help you catch that. And some people are going even further with it, which is what's cool about open source, I guess. They're setting policies based on costs. So if this pull request is going to increase the cost by more than, say, $10,000, someone should probably review this thing. All of this is to kind of try and get people to love their cloud bill. And by that, I mean, the cloud bill isn't something that people fear and they're shocked by. It's actually something they're proud of. They can point to the pull requests that reduce their costs and say, look, we're spending efficiently, and you can even show that off to the rest of the team or to the rest of the company, because you're not wasting cloud resources. You're kind of using things efficiently. So that's, I guess, the ultimate benefit of this. How does it work behind the scene? So the CLI, and there's two pieces. There's a CLI piece, and then there's a cloud pricing API piece. Both of them are open source. The CLI parses the Terraform plan JSON. That's the main thing we kind of rely on just now. And it finds anything that has a cost-related parameter. It then makes a call to the cloud pricing API to find prices for those things. And obviously, no credentials or secrets are sent over to that API. That's why there's a CLI piece. And the CLI then computes the cost estimates, and it outputs text, HTML, or JSON. So there's a couple of technical challenges to doing cost estimation. When we're implementing that first one, we have to essentially map the pricing web pages on Amazon or Azure or Google to Terraform resources and Terraform parameters. And that might seem easy, but for something like S3, that took about a week to code. Now, what's beautiful about that is once it's coded up, everyone in the community can now just get a cost estimate for that resource very quickly. So that's the first challenge. Once we do that, then you get to things like AWS Lambda and cloud storage. What do we do for them? Because I don't know the costs, but I can explain the prices to you. So that was the first iteration. We just showed users the prices for these services. Then we said, what if there's a YAML file and you can put in some values? So if my Lambda takes 250 milliseconds average response time and it's invocated 2 million times a month, how much would that cost me? So you can do quick what if analysis. And the current iteration we're working on is, well, what if we connect to CloudWatch for things that are already deployed, like Lambda, for that Lambda example, and we fetch the usage for the last 30 days. That way, the people can do what if in their workspace, in their kind of workflow, without having to guess. Now, even when you do all of that, there's things like reserved instances, custom price books, discounts that all apply at larger companies. So my point is cost estimation isn't easy, and those are other challenges we kind of have to get to. And that's where the community comes in. So here's an example. Here's some of the ways that the community has been contributing on this project so far. We've had more than 50 amazing contributors. This is a picture of just some of them. And mainly what we're seeing is DevOps, SRE, people who are working with those Terraform resources. They're coming in and they're adding the mappings between the prices and they're writing the code to kind of calculate the costs for that resource. We've done this for about 200 Terraform resources, and we've identified about 500 Terraform resources that are free. That's the main thing that's been amazing to see from the community. And then there are people doing all sorts of interesting stuff with the CLI in their CI/CD pipelines. And they, of course, run into bugs. They have feedback for us, so they create GitHub issues or discussions, and we work on them. And finally, just sharing the use cases. We've seen teams take the JSON outputs and set up streams where their security teams and their FinOps teams are getting heads up of what's coming in the CI/CD pipelines as things are being worked on it. And when those use cases are shared with us, some of them are super interesting because they might fit into the core product. So I'm going to show you a quick demo using this new thing that HashiCorp released in Terraform Cloud, which is in private beta by Terraform Cloud, and it's called Run Tasks. The same thing I'm going to demo, you can do with GitHub Actions, GitLab CI, any of the other CI/CD systems, really, because it's a CLI tool, there's a Docker image, you can use that. So, like I mentioned, the run tasks in Terraform Cloud is in private beta, but you can request using this link here. Once Terraform Cloud enables the flag on your account, you can then go here, just enter your name and email, and we'll generate a webhook and an HMAC key that you can then take over to this page here in the settings of your Terraform Cloud account, and you put those in, and then that's it. The integration is kind of set up. You can then enable Infracost on any workspace you want. And then anytime after that, all of the runs get a cost estimate. So you can see the output here, which shows like this pull request is going to increase the cost by this much. And then there's this link. The link is a pre-authenticated link, and it will take you over to a page like this that you can share that link with the rest of the team. And it shows a diff or a table view of the Infracost output in exactly the same way that you would have gotten had you run it with the CLI yourself. So it's basically the managed version of the CLI. The cool thing is that you have these pre-authenticated links and you can then share them with the rest of your team. That's all I got. You can try Infracost here. That's the docs. And if you'd like to contribute, there's a GitHub link. And thanks for listening. I think we still have a little bit of time if people have any questions. I haven't been looking at the group chat. So I'm happy to answer any questions. If not, I think Anton wanted to talk about something as well.
Well, yeah, I always want to talk about something. So, well, in this regard, I have actually something to highlight for everyone who is interested in bringing Infracost closer to developers. So when we have a pull request, and as Ali just explained, the flow is great. I mean, the flow is quite obvious. We have CI/CD pipeline. We have place where we can execute Infracost. But I find it rather beneficial to have possibility to run Infracost when you do actual commit. So imagine that you have Terraform configurations and you have possibility to run Terraform plan. It's not always possible, but let's say you have possibility to do this. And you want to make sure that you are not committing something what is really expensive or well, for example, you are developing a module and you want to make sure that this module is not going to cost fortune for everyone just by accident. You have possibility to run Terraform plan. So what you need to do is try to think about Infracost the same way as you think about Terraform FMT, Terraform Validate, Terraform Lint. All of these tools you run on developer's machine before you commit code. So what we have is we have developed a pre-commit Terraform hook, which is almost there. It will be released, I think, during this week. And the purpose of it is to have possibility for developers to specify one more hook which they can run when they commit code. It is rather early in terms of whether there is even need for that, but I find it's quite helpful for people to make sure that they are not able to do something very expensive just by accident. It does not restrict normal usage of Infracost the way Ali was explaining, but it's good indicator that something has been evaluated and you didn't commit code which is going to cost you a lot. So some like first level checks are pretty useful, I think. As I said, I don't know if there is even need for that, to be honest, but I find it quite cool.
Yeah, in a lot of ways, this this project is being pulled by the community, and we are constantly surprised by what people are kind of exploring with it and doing with it, and that's why I think this open source thing just works.
Yeah, there is another ways or multiple ways how this can be integrated. And I also agree that it makes a lot of sense to try out different things, like put it in all possible places, and then you will see how people are using it. So that's the beauty of open source.
Yeah, especially for like early on projects. And we're seeing a lot of kind of early adopters who want to kind of explore these things. They already have Cost Explorer, they already have those things, but they're not proactive. They still get them shocks and surprises. And they're trying to kind of change that. So I
sent link to this pull request if anyone wants to take a look. So yeah. that's all from me for now.
Awesome. Perfectly timed. They told us about 15 minutes. That's 15 minutes. So I'm going to stop the recording. And thanks, everyone.